Hello and welcome to the Future Energy Perspectives interview, brought to you by Power Engineering International and Siemens Energy. I'm Kelvin Ross, I'm Editor-in-Chief of Power Engineering International, and today we're talking clean fuels. That's hydrogen, e-fuels, biofuels, and a whole load of others. And to take a deep dive into this subject, I'm joined by Erik Zindel, who is Vice President of Generation Sales for Hydrogen at Siemens Energy. Currently, he's leading the company's initiative for hydrogen combustion in gas turbines, and he's also involved in all other aspects of Siemens Energy's hydrogen strategy. So we are very honoured and lucky to have him today. Erik, thanks for joining me today.
Thank you very much. Yeah.
There are several examples out there, and indeed in your article that you've written for the Future Energy Perspective series, of clean fuels being deployed in CHP plants. And so my first question is, I'm wondering, what is the reason why cogeneration facilities are looking into these fuels?
Well, I think the main reason is climate change and the need for decarbonization. We need to ensure that the whole power system is completely decarbonized in the next 2 to 3 decades. And that means we have to go away with any fossil fuels. That means no coal, no liquid fuels, at least no liquid fossil fuels, and no natural gas. And that applies both for combined cycle power plants, gas turbines, but as well cogeneration plants. In the future, we're going to have a system which will be mainly driven with renewable energy. And most of the renewable energy will be intermittent sources of energy. That means solar and wind energy. And there will be times of the year where there will be a surplus of renewable energy, but also times of the year where there will be a lack. And then the point is, every time we have sufficient renewable energy, then you would assume you will run the electrical system just on renewable power. For heating applications, we'll probably see heat pumps as being the main source of heating. Same applies for cooling. But there are always this 15 or 25% of the hours of the year where there will be not enough renewable energy in the system. And then we have to make use of conventional thermal generation like gas turbines, combined cycles. And the only point is they will have to run on a clean fuel. That could be hydrogen, could be biofuels, could be some hydrogen derivatives. And cogeneration is a very special case because today cogeneration is being used as a way of providing both power and heat from the same fuel in a very efficient way. In the future, we're going to still see cogeneration, but the role will be a slightly different one. As I said before, most of the time of the year we'll be able to run a heating system based on heat pumps. But those 10, 15, 25% of the hours of the year where there is not enough renewable power in the system also is the time where there is not enough renewable power to run the heat pumps. So the residual load for the power system coincides with the residual load for the heat demand, and then it makes sense to combine both functions, provide CO2-free electricity from both combined cycle and the cogeneration with a clean fuel to provide both power and heat at the same time. So that's the main reason why cogeneration in the future will also have to look into a green fuel, because natural gas is not longer to be a suitable fuel for the future, unless you do obviously carbon capture storage, but that will be limited to some opportunities only.
Yeah, sure. And then that future that you've just described, I think everyone accepts that future will be increasingly decentralized. So of the fuels that you've touched on there and the others that you deal with in your article, which fuels are perhaps, or are any fuels particularly best suited for a decentralized energy landscape?
I think the fuels for decentralized energy will also be the same fuels as for centralized generation. We're going to see still both applications, but maybe slightly more decentralized than what we see today. But the first option is always hydrogen. Hydrogen, because it's the easiest way to produce decarbonized fuel out of renewable power, green hydrogen. And that allows us as well to overbuild the renewable energy in the future. As I said, we will need to produce hydrogen from renewable energy, but only if we can really increase the amount of renewable energy significantly without going into curtailment issues. Then we can really make use of this excess renewable to produce hydrogen that we will re-electrify at a later stage. So that would always be probably the cheapest and most efficient decarbonized fuel in the future for the residual power and the residual heat operation. But unfortunately, hydrogen will not work everywhere, simply because there are situations, locations where we will not expect to have sufficient amounts of green hydrogen fueled from a gas pipeline network, or even no hydrogen at all. And then we have to look into different fuels. And those could be, for instance, biogenic fuels, biofuels like, for instance, HVO, hydrogenated vegetable oil. It could be a biogas, biomethane, also bioethanol, and it can be any sort of hydrogen derivatives. Think about methanol, e-methanol, then as well ammonia as a very important future energy vector. So we couldn't, for instance, produce hydrogen in a different continent, convert it to e-ammonia and transport it as ammonia into the port of destination, and then we could use ammonia as a fuel, probably not directly, but after cracking, where we can then burn the resulting hydrogen again in the gas turbine. So it's a matter of different fuels that will be available. It will very much depend on local conditions, what is available. Hydrogen would always be option number one, but for the others, especially when we talk about islands, for instance, we need to look more into fuels that we can store as well in liquid form.
Mm-hmm. You mentioned gas turbines there in your answer, and Siemens Energy is still building state-of-the-art combined cycle plants, notably Keadby 2 here in the UK. So when you're building a plant like Keadby, but looking to the future, how will these clean fuels come into play for a baseload power plant like Keadby 2?
Yeah. Well, first, Keadby 2 and probably as most of the combined cycle power plants will not longer be baseload plants. We're already seeing that most gas plants are running probably in a sort of an intermediate load, running between 2,000 and 4,000, 5,000 hours a year. And with future break-in of renewable energy, we're going to see combined cycles being pushed to more the peaking load and the residual load for those periods of the year where there's not enough wind and solar in the system. That means we're going to see combined cycles more or less backing up the renewables. And for new power plants like Keadby, obviously, as of today, green hydrogen is not yet available. First, not in a physical form. We simply don't have enough green hydrogen capacities available. Also, the fuel infrastructure is not there. So we have to run these power plants still on natural gas for the next couple of years. But the intention is obviously, as years pass by and we build up this hydrogen backbone infrastructure and we have additional renewable energy being used to provide green hydrogen, then these plants will slowly then switch over to hydrogen as a green fuel. And that means that for new power plants, we have to build them in a way that we can then later convert them, for instance, into hydrogen combustion. Which means we have to prepare the plants so that we take the future hydrogen operation into consideration when we build the power plants. And that means, for instance, making sure that we have selected the right materials for the fuel gas system, that you have designed the power plant with sufficient free space for those additional systems that we will require in the future, like innertization systems, a mixing system, maybe some additional ventilation systems, and as well explosion-proof hydrogen power plants will have to be built to a different gas classification to C, and all that is rather be done at the beginning when you build the power plant, because retrofitting that later might be quite expensive and disruptful. Obviously, some topics you will leave for a later retrofit, things like changing the burners for hydrogen. That is something that you will do later. As well, if you need to add some additional SCR for NOx emissions, that's also something that you would do later if you don't need it from the beginning. But at least you make sure that you have prepared the plant for a later retrofit. This is what we call H2 readiness of a power plant. So it does not mean that the power plant is already capable of running on hydrogen from day one, but prepared for a later retrofit. And that is what we see with most of the power plant projects that we are currently discussing with customers. Everybody really wants to have a power plant that will run on natural gas in the next couple of years, but be prepared for a later retrofit to up to 100% hydrogen in the future.
Mm-hmm. And for that network, that supply chain, if you like, for hydrogen to fully enable that transition to green hydrogen, as you say, a lot of elements aren't in place at the moment. The generation from renewables, the pipelines, the storage. Are you able to take a best guess at when these things might be in place? And I just wonder what's perhaps the biggest challenge to establishing that network?
Yeah, obviously, best guess. I can give a best guess, but I cannot look into the future, obviously. But in general, as you said, we need to build additional renewable energy. We need to build the electrolysis systems to produce the hydrogen, and then to transport it to the power plants. And that can only be done really with a hydrogen network infrastructure, because at least when we talk about larger gas turbines above 5, 6, 7, 10 megawatts, you cannot operate these with trucked hydrogen. You really need a connection to a hydrogen network. And currently the plans, at least in Europe, are to begin to work on a hydrogen backbone network in parallel to the existing natural gas network. Fortunately, it's possible to isolate individual branches of the natural gas network and to convert pipes that are currently running on methane to convert them on hydrogen. And with only some additional new build construction, we can begin to work on building up a hydrogen backbone infrastructure with 100% hydrogen from the beginning. That will also allow us to connect any underground storage that we will also need from the beginning, because renewable energy will also always carry a significant seasonality in its production. So the plan is at the moment from the large European transmission system operators to begin to work on the backbone network in the next couple of years. We already have the first small hydrogen grids available, currently running on gray hydrogen. And over time, we're going to see more and more large pipeline systems being converted and built for hydrogen, so that by 2030, we might already have beginning of what you could see a network of hydrogen pipelines in Europe. And by 2040, we're going to see probably a more detailed mesh of networks. And that will probably allow most of the power plants to be connected to the hydrogen network. And that will give us then availability to hydrogen. All assuming that obviously we'll build also the renewable power from in the next couple of years. And in any case, we're talking about a regional network. And region, I mean continent-wide.
Erik, you mentioned transportation in your answer there, and I'm wondering how important is a particular type of transportation to some of these fuels? Are some of them dependent on road transport? Are some of them dependent on access to shipping routes and ports? And if so, what does that make ports in some cases, an ideal hub for clean fuels?
Yeah, obviously, hydrogen is probably the most difficult fuel to transport, and it really requires a gas pipeline infrastructure. So with the exception of very small projects, small isolated turbines and engines and fuel cells, you will always need a pipeline supply of hydrogen if you want to use it for power generation and for cogeneration. You cannot truck the hydrogen to site all the time. That's the amounts are simply too large. For all the other fuels, as long as it's liquid, they're very easy to transport because liquid fuels can be transported in pipelines, can be transported as well with trains or with truckloads, can be stored as well on site. That's one of the big advantages of liquid fuels. And obviously ports will become important when we talk about import of green fuels. We'll not always have the situation that we will be able to produce the green fuel next to the power plant. Rather the opposite. We're going to see a very varied way of producing green fuels in some parts of the world where there are good conditions for renewable energy, good conditions for biomass. On the other hand, the combined cycles and the cogeneration plants will always be located close to the consumers, especially the heat consumers. And that will always mean that we're going to rather transport the fuels rather than the electrons and the heat, which is also, by the way, the much more efficient way to transporting energy. It's always better to transport a molecule than an electron. And that means ports will be key to import fuels on large scale. They can also become a very important import location for hydrogen in large amounts, especially when we talk about ammonia as a hydrogen carrier. And in the future, we can expect large ports to be developed into as well energy import infrastructure that can feed hydrogen into the gas pipeline system, but as well being a hub for other decarbonized fuels like biofuels and hydrogen derivatives like ammonia and e-fuels.
Mm-hmm. There are lots of concerns over energy security and independence at the moment. If the availability of natural gas becomes scarce or scarcer than it is, and that in turn creates a need to accelerate the deployment of the clean fuels that we've been talking about, is it possible to accelerate? Is it possible to go faster to deploy these fuels? And if it is, will that mean there's some sort of trade-off, some compromise on their greenness? Will we move to less greener versions of them just to have the availability of them?
Well, what we see today is effectively we have an issue in the supply of natural gas, especially in Europe, a very serious one. And worldwide, we're seeing currently very high prices in general for natural gas and for LNG. That is definitely pushing towards a quicker energy transition towards hydrogen and other clean fuels. The only point is you cannot really ramp up the hydrogen world in a matter of months. This is something that will take 1-2 decades in total. So what we're seeing is increased pressure to be quicker with the energy transition, but it's simply not going to solve the problems that we're going to have in the next 2 winters. Simply because we talk about additional renewable energy, we need to provide the electrolysis plants, we need to provide all the hydrogen infrastructure with the pipelines. That is not something that we're going to do in the next 2 years. But effectively what we'll see is really we are speeding up with the energy transition. And also one of the points that is worthwhile mentioning, the current prices for natural gas are so high that would we have today green hydrogen in large scale available in a hydrogen grid, it would be probably already cheaper than the natural gas price as of today.
Yeah, interesting point there. Final question. There's a lot of things to be pessimistic about these days, but what's the one thing that you are most excited about and looking forward to? What's the thing that energizes you about the energy transition?
In general, I'm much more optimistic than pessimistic. Obviously, it's a big challenge in front of us, but compared with the situation maybe 5, 10, or 15 years ago, we really see today the possibility of decarbonizing our world. Not just the power sector and the heat sector, but all the other sectors of the economy. And that is a very bright future that we have in our world. At the end, we can really go towards a clean planet and solve the issue of climate change and global warming. Obviously, there is some global warming that we already have produced, and we're going still to increase the global warming, but we see still the potential to keep to the 1.5 to 2 degrees, but we have to speed up significantly in the next few years, all around the world, in all the sectors in the economy. But it's something that it's technically viable and commercially it's within reach. It's definitely much cheaper than if it would not do anything and let global warming produce all the catastrophes that we're going probably to see in the next 50 to 100 years. So we'd rather change now, otherwise it will be even more expensive in the future. And it's a cleaner world, it's a more healthier world as well. And for me, that's a very bright future, and we should not underestimate all these technologies are still very new. They're at the beginning of their technology learning curve, which means that over the next years, we're going to see significant improvements in terms of efficiencies, economies of scale, economies of number, efficiency increases, more R&D being put into these technologies, so new R&D breakthroughs as well. And we're going to see something similar to what happened with renewable energy, with solar and wind power in the last 20 years, where 15, 20 years ago, even I was very much sure that these renewable energies will never get to the cost levels of conventional generation. And now it's a third of the price or a fourth of the price. And we're going to see exactly the same with these green technologies like hydrogen. In 10, 15 years, we'll see the break even, and they will become cheaper than the conventional fossil fuel technologies. And it will be a significant amount of investments. It will completely change the way how we produce and use energy in all the sectors. So we're really just beginning with the energy transition, but I think it's a very bright future, and we're here at least to support the world in getting cleaner energy in the future.
Mm-hmm. I think it's a bright future too. I think you're quite right. It's in some ways you can't underestimate the potential of these technologies because we don't yet know what the limits of these technologies are. So that does make it an optimistic future. So thank you.
And even more, it's important to understand that when we talk about new technologies, people tend to overestimate the potential short term, but tend to underestimate it long term. So there is probably a little bit of hype at the moment, but on the long term, it will probably at the end still be quicker than what we would expect today.
Yeah, absolutely. Interesting. Yes, I would agree with you there as well about that short and long term vision. Erik, it's been great. We've had a fantastic discussion. I've really enjoyed it. Thank you very much for joining me today.
It was a pleasure for me as well.
Thank you. To everyone watching or listening, if you want more insights into clean fuel, do please catch up with Erik's article, which is available on the PEI website, as are all the previous articles, interviews and podcasts in our Future Energy Perspective series with Siemens Energy. But for now, thank you very much for watching, and we'll see you again soon.
Thank you. Bye-bye.